In this lesson, I'll show you how to find the area of a polar region. This is question number 2. The question reads, find the area of one loop of the equation r is equal to 2 cosine 4 theta. If you graph this, it will look like this. Now let's go ahead and set this up. We'll use the following formula where we have a is equal to the integral between a and b, which hasn't been provided for us. For the integrand, half where r is equal to the following, 2 cosine 4 theta to the power of 2 d theta. As I mentioned, we haven't been given the bounds, but you can find the bounds by looking at this carefully. Notice that r is at 0 twice for each of these loops. Take, for example, this loop. You'll have r is equal to 0 in the middle. So by setting this equation to 0, for example, 0 is equal to 2 cosine 4 theta, I can solve for theta here. I'll divide both sides by 2. That gets rid of this 2. And on the left side, we have 0 over 2, which is 0, is equal to cosine 4 theta. Now, if I do cosine inverse of both sides, where I have cosine inverse of 0 is equal to 4 pi, cosine inverse of 0 is 90 degrees, or pi over 2. And if I keep adding pi to this, I'll end up with 3 pi over 2, then subsequently 5 pi over 2, and so on. And of course, each of these will be plus minus, depending on which direction you're going. And this is equal to 4 pi. Now, if I divide each of these numbers by 4, I'll end up with pi over 8, 3 pi over 8, 5 pi over 8, and so on. So any consecutive two angles we choose of these three will work. So if I set my lower bound as pi over 8, my upper bound has to be 3 pi over 8. So let's go ahead and input these bounds into here. This right here will be pi over 8, and this will be 3 pi over 8. Here's what we do next. I'll pull out this 1 over 2 factor. It doesn't need to be integrated, where I have area is equal to 0.5, which is 1 over 2, times the integral between pi over 8 and 3 pi over 8. And the rest, we have 2 to the power of 2 cosine squared 4 theta d theta. What I did was I distributed this 2 to the factor 2 and to the cosine. This gives me a is equal to 0.5 times, and I'll pull out this 4, times 4, times the integral between pi over 8 and 3 pi over 8, cosine squared 4 theta d theta. In order to integrate this expression, I'll need to convert this into a half-angle identity. There's a half-angle identity that looks like this, where you have cosine 2 theta is equal to half bracket 1 plus cosine 2 theta. Here we have 4 theta. The only difference is that over here we have 4 theta, and here we have theta. So this part right here will be multiplied by 4, giving us 4 theta times 2 is 8. Therefore, I'll integrate. A is equal to 2, remember this is equal to 2 times the integral between pi over 8 and 3 pi over 8. Then we have half bracket 1 plus cosine 8 theta d theta. Pulling out this half, 2 times half is equal to 1, times the integral between the same bounds as before. And now we need to integrate 1 and cosine 8 theta. Not hard to do. In fact, the integral of 1 is equal to theta. We can pull that out. Plus, now we have the integral of this expression. To do this, we'll set this equal to u. So now we have the integral of cosine u d theta, taking the derivative of 8 theta to make it in terms of u. We have du is equal to 8 d theta, and this now becomes du over 8. I'll pull out this 1 over 8 outside, leaving us with theta plus 1 over 8 times the integral of cosine u, which is sine u. And remember, u is 8 theta, And we have to evaluate this at our upper and lower bounds. We're almost done. Let's use our calculator for this. We have 3 pi over 8. I've just inputted it into there, plus 1 over 8 times sine of 8 times pi over 8. That gives me 3 pi over 8 minus, and we'll do the same thing, starting with pi over 8, which I'll put in brackets, plus 1 over 8 sine of 8 times pi over 8, which is simply pi. Subtracting this from that, we end up with 2 pi over 8, which is equal to pi over 4. That right there represents the area bounded within one loop. And there you have it. That is how to find the area of a polar region.